Hello, and welcome to Lesson 1-6 in Math 1025. This section is titled What are the Chances? And you will be learning about basic probability. So we'll go through and do the classwork together. Classwork starts towards the bottom of page 75, and they give us a really nice visual diagram of what we're talking about when we're talking about probability. They define probability for us. Probability is the probability of an event occurring is the description of how likely it is that that event will actually happen. Probability can be described using a number between 0 and 1. That would be a decimal or a fraction. You could do a percentage between 0 and 100. You could also use words like impossible, unlikely, even, likely, or certain. And this visual gives us a really nice example of the spectrum from 0 to 1. This would also be in percentage from 0% to 100%. So 0 means it is never going to happen. It is absolutely impossible to happen. For example, if you had a two-headed coin, your probability of flipping a tails would be 0. Unlikely means it will happen sometimes, but more often than not, it will not. So your odds of rolling any specific number on a number cube would be 1 out of 6. That's pretty unlikely, but it does happen sometimes. Even chances like flipping a coin. You have heads or tails, so you have a 50-50 chance of getting either one of those, or a 1/2 probability. Likely means it's more often going to occur than not. And the example they give here is a poker hand. 5 cards, 8 of those cards are 8s. And the probability of pulling an 8 out, if you're looking at the backs of the cards, would be 4 out of 5. So it's pretty likely that you're going to pull an 8, but not all the time. 100% means it's certain, it's absolutely always going to happen. So again, going back to our two-headed coin, 100% of the time I'm going to flip heads, since it's heads on both sides. And they do exist, you can find those. They're not spendable, but they do exist. On page 76, it's mentioned that the probability of rolling a 4 on a number cube is 1 out of 6, because there's one side with 4 dots, and then there's 6 other sides. They want me to write this probability as a decimal and as a percentage. So we're talking about 1/6. Fractions just mean division. That fraction bar is a division sign. So I can get out my calculator and turn it on and take 1 divided by 6. And my calculator will tell me that that is 0.166666 repeating. They did ask me to round it to 3 decimal places. So I'm going to say my answer is 0.167. Just so you know where that's coming from, when I had this 0.1 with a bunch of 6s here, they asked me to round to 3 decimal places, so that's this number here. The number after it will tell me what to do. If it's a 5, 6, 7, 8, or 9, it bumps the number before it up. If it's a 0, 1, 2, 3, or 4, it stays the same. So that's why our 6 became a 7. And then they asked me to do that, to write it as a percent. So as a percent, I could either manually move the decimal 2 places over and say that my answer is 16.7%. Or I could get out my calculator again and multiply the answer I got by 100. So we have 16.7%. Number 2 wants us to write a sentence describing the percent chance of rolling a 4 with 1 standard die. I would say, I will roll a 4 about 16.7% of the time. Three asks us to expand our rolls. So now instead of rolling it 1 time, we're going to roll it 300 times. So I'm rolling it 300 times. I know that about 1/6 of that time, I can expect it to be a 4. So I just take 300 times 1/6. And again, I can use my calculator for this. I can do 300 times, and I can do parentheses 1 divided by 6. That's probably the easiest way to type in a fraction. It's the way I had to for years and years and years because the graphing calculators used to not have fraction buttons built in. I'll show you where that is in a second. And I get an answer of 50. But I did want to mention most of the newer calculators now do have a fraction bar built in. You can access it a couple different ways. Alpha y equals will take you to the fraction menu. And if I hit enter, you'll see it gives me the nice little boxes to put the top and bottom in. So I could type 1, use my arrows to move down for the 6, and then multiply that by 300, and it gives me the same answer. The other place you can access this is through the math menu. If I arrow over to the number part and I scroll way down until I find the same fraction buttons, you see all of them showing up here. These are all of our fraction menu, and then I can hit enter on the one that looks like a single fraction, and then it gives me the same stuff again. So it is nice that that's been built in. That's only in the past 5 to 7 years. So if you have an older calculator, it may not have that. All right, so we just said number 3, we expect to get a 4 50 times. How sure are you that we'll get a 4 exactly 50 times? Not very. It's not very likely. We'll get close to 50. But the odds of rolling exactly 50 times are pretty slim. So I'll approach 50, I'll be near 50, but in any given trial of 300 rolls, it's unlikely that it will be exactly 50. So switching gears a little bit, we're going to start talking about the word outcome. Outcome is the different possible results. And we're going to switch gears from our die, which had 6 outcomes, and we're going to be talking about a coin. How many possible outcomes are there on a coin? There are 2. What are those possible outcomes? Heads or tails. So we have a chance of getting heads or a chance of getting tails. There's 2 possible outcomes. At the top of page 77, they want us to answer what is the percent chance that a single coin lands on heads when flipped. So I flip the coin. I want to know what the probability is that it will be heads. They did ask me to answer it in percent, but I might have to start with the fraction. There's 1 head out of 2 possible outcomes. So again, I can get my calculator out and do 1 divided by 2. This might be one that you're comfortable with. This is sometimes called a benchmark fraction because we know it. It's 0.5%. And again, I can either move my decimal 2 places to the right and say that it's 50%, or I can use my calculator and multiply that number by 100. All right, number 7 wants that same answer as a fraction, which we already did. It's 1 out of 2. And they want me to describe the likelihood verbally. It is an even chance. Or 1 time out of every 2 flips, I will get heads. Purple boxes are usually significant because they mean something important. This purple box is telling me, first of all, how we calculate probability. That's the fraction on the right. And it's also showing me what probability notation looks like. Probability notation looks like P parentheses some outcome. In the math world, we often think of parentheses as times. They don't mean that in this case. So if I read at the bottom of the purple box, it says P parentheses rolling 4. That means the probability of rolling a 4. And we know that's 1 over 6. We just did that up at number 1. You could shorten that probability notation to just say P of 4 is 1/6. But it does not mean P times 4. Number 8 says if I flipped a penny 80 times, how many times would I expect it to land heads up? Well, we know it's going to be heads about half the time. Multiply that by 80, and I would expect to get heads about 40 times. And then 9 is very similar to what we talked about with the number cube. Would I expect to get 40? Exactly. Not likely. We know, we've all flipped coins enough to know that it doesn't always split evenly. It could be 3 heads and 7 tails. Turning to page 78, Number 10 says the probability diagram on page 75 talks about a good hand in poker. 4 eights. If you were to randomly pick a card from that hand, what is the probability that it would be an 8? They want me to write it as a fraction between 0 and 1 and as a percent. So how many 8s were in that hand? They even told me that here, so I don't have to even turn the page to go back. There were 4 of them. Out of how many total cards? There were 5 total cards. So that's my answer as a fraction. To write it as a percent, I need to take 4 divided by 5. So 4 divided by 5. It's 0.8 as a decimal, 0.8. And then multiply by 100 to get your percent. So about 80% of the time, we expect to pull an 8 out of that hand. 11 looks at the other side of that. What's the probability of pulling a king out? And they do want it in percent. Again, that's going to be important when you do your homework to notice what they're asking for. There is 1 king in that hand out of 5 possible cards. If I take 1 divided by 5, I get 0.2, and then I'm going to multiply that by 100 to turn it into a percent, and I get 20%. So 20% of the time I would expect to pull the king out of the card. Just a quick note, what is 80% plus 20%? It should be 100%. So it's the total possible outcomes would be 100%. About the middle of this page, they hit something that's pretty important. They talk about, we haven't really done any experiments. We have been looking at what's called theoretical probability. This is what we assume we should get. So we're based on observing how many outcomes are possible and then how many fit what we're trying to look for. So that's theoretical probability. But there are some cases where theoretical probability may not work very well, and that's where we're going to look at empirical probability. It's also called experimental probability, and that's the way I learned it, as experimental probability. And I like that word a little bit better because it tells us we're actually going to do the trial. We're going to roll the die 100 times and see how many times 4 comes up and then figure out that percent. So that's what we actually got when we did the experiment. So empirical probability is we do it and we see what happens. And that is basically all there is to know about probability. As you go into your groups, you'll be looking at some experimental or empirical probability and working with that. I hope you have an excellent day.